right, hi everyone. This is lesson 3 of the polynomials unit. We're going to be multiplying and dividing monomials today. So monomials, remember, are polynomials with one term. We are going to do it visually because some students, that helps them understand the process, and then we will just do it with symbolically afterwards. Okay. So when we represent multiplication visually, sometimes we like to think of it like a rectangle, because the area of a rectangle is length times width. So if we set these two numbers up as our length and our width, then we can see what the area would be, or what rectangle would be created, and that's what the result is. So if we set these up, we can see that the rectangle is this large, and it would be represented by squares of length x by x. So that would be x squared, x squared, x squared, x squared, x squared, and x squared. Now they would all be positive because the two values are positive. Positive multiplied with a positive is a positive. So the final result is I have 6 x squared tiles. So essentially what you end up doing when you multiply, the rule is you're going to multiply the numbers together. 3 times 2 is 6, and multiply the variables together. X times x makes x squared. Okay, let's try another one. 4x multiplied with negative x. So again, we're making a rectangle, this being the length and this being the width. And let's see what we get, and if this has the same, if the rule holds up. So when we multiply a positive and a negative, we get a negative. So this is going to be negative x squared. Negative x squared. To fill the space, we're going to make 4 negative x squared tiles. So again, we see the rule fits. Oh, not negative 4 of them. We multiply the numbers and we multiply the variables. Okay, let's do it without the pictures now. So one way I like to do it the first few times through is I like to write this out in a different order, because you can multiply terms in any order that you want. Like 2 times 3 is the same as 3 times 2, right? So the first time I do this with students, sometimes I like to write it out with everything separated like this, with those dots are just multiplication. And I like to change the order so they can see it a little bit better. Okay, so what we're going to do is just multiply negative 2 times 5, and we're going to multiply x times x. So the result will be negative 10, and x times x can be represented with x squared. And that's the final answer. Now you don't have to do all those steps every single time, but it is nice to visualize the first couple times we do it. Let's do that again here. We're going to write this all out as separate multiplication. We have x times x for the x squared, 4, and then another x. Okay, let's rearrange it. Okay, so we've got these two numbers multiplied with these variables. And I just changed the order because multiplication can be done in any order you like. So the numbers being multiplied together is going to give us negative 12. And then there are 3 x's, so it'd be x cubed. Okay. All right, next one. So this one, 6 times x times 3 times y squared. Okay, let's rearrange the order. This time I have 3 different types of terms here. I've got an x, and then I have a y squared. Okay, so I'm going to change it so that the two numbers are beside each other, and then I'm going to have an x and a y squared. Now when the variables are not matching, we can't combine them. They're totally different, so we just leave them, but we can multiply those numbers together, so that would give us 18, and then we just write xy squared. So we multiplied the numbers We did technically multiply the variables, but we can't combine them in any way because the letters are different. Okay, great. Let's try dividing monomials. When I divide monomials, I like to think of it like, I like to write it as a fraction instead of like with the division symbol like this. So if I'm given this question, I typically rewrite it, especially the first time I'm teaching students, like this. And we can do the division in kind of the same way as we did the multiplication. We can think of this as 8 divided by negative 2 and x squared divided by x. So 8 divided by negative 2 is negative 4. And if you recall back to the exponents unit, we subtract exponents when we're dividing them. So x squared minus, or 2 minus 1 would be 1, so it'd be x. Okay, so in the same way that we did the multiplication, we can do the division that way also. Let's do this one. I'm going to write it out just really separated, 3 times y. So here I have 15 divided by 3. That's going to give me 5. Then I have an x term in the numerator that I don't have in the denominator. And then in the numerator and denominator I have y. So let's do the numbers first. 15 divided by 3 is 5. There is no division to do with the x, so it's just going to be in my final answer. And then when you have y divided by y, that completely cancels out. 1 minus 1 would be 0. So we leave it out of our final answer. It'd be y to the power of 0, which is 1 anyway, so it doesn't need to be written. And that's our final answer, 5x. Okay, and then finally, let's do this one. Let's try doing this one without rewriting it. So we've got our numbers here. Then we have our x's and our y's. Okay, so let's do the numbers first. Negative 36 divided by negative 9 would be 4. X squared divided by x, remember subtract the powers. So 2 minus 1 would give us 1. And then 1 minus 1 would give us 0. The y's just cancel out completely. We don't need to write that power of 1, so I'm going to leave it off. So we ended up with 4x. All right. Lastly, just a little bit of a connection to some more geometry. Let's write some expressions for area because we do need to multiply when we're finding area. So it's a good application of what we've learned today. If you want to pause the video and try these on your own first, you could. All right, let's start with the rectangle. So if you recall, area of a rectangle is length times width. So the area is going to be 8x multiplied with 3x. Remember that we multiply the numbers together and then we multiply the variables together. So this is going to be 24, and then x times x is x squared, right? The numbers and the variables. Okay, let's do the triangle. You might recall the area of a triangle is length times width divided by 2, or times 1/2. Let's try it. So area is going to be, and when you do length and width, or base and height, sometimes people call it, it has to be the two lengths that are perpendicular to each other. So we're going to ignore the 5x completely. We don't need it. So it's going to be 6x times 4x, and then all of that divided by 2. So remember, we multiply the numbers. We could change the order if we like, so they're beside each other. 6 times 4 is 24. And then x times x is x squared. And we're going to divide that by 2. So it's going to be 12x squared. Okay, and lastly, we have a circle. You might remember that for area of a circle, it's pi times radius squared. So here, it's going to be pi times 3x. Squared just means multiply twice. Like this. And remember again, we're going to multiply the numbers and multiply the variables. We also have another symbol here, pi, and we're going to, that could be considered, I mean, it is a number. We want to give our answer as exact, so we're going to leave that in our answer too. So multiplying the numbers together, we would get 9. We're going to leave the pi there, and then we'll have x squared. So we have 9. From those two 3's multiplied together, we have the pi, and we have the x times x, which makes x squared. All right, that is the end of the lesson.